Good evening, everyone. Hello, welcome back to TMLS 2020. I'm Beta, and I'm a researcher and data scientist at Ryerson University. I'm honored to be your host for this session and introduce one of our greatest speakers, Jaya Kawale. During the talk, if you have any questions, post it in the chat section. I will make sure that at the end of the talk, we get back to all of them. Now let's introduce Jaya. Jaya is the director of machine learning at Tubi, leading all of the machine learning efforts at Tubi, encompassing homepage recommendations, content understanding, and ads. Prior to Tubi, she had worked on different aspects of recommender system at Netflix and Adobe Research Labs. She did her PhD from the University of Minnesota, and her thesis won several awards, including the Explorations in Science Using Computation Award. She has published many top-tier conference and journal papers. Without further ado, get back to you, Jaya.
Thank you for the kind words. I'm extremely happy to be back. I had a really good time last year. Unfortunately, we cannot meet in person, but I'm just amazed at how well this conference is organized. So thank you so much for inviting me once again. Let me share my screen. So hi, everyone. I'm Jaya Kawale, and today I want to talk to you about understanding content using deep learning techniques for NLP. I'm not sure if you have heard of Tubi, but Tubi is an advertiser-based video on demand service. So what that means is that it allows its users to watch content online. It's a free service, so anybody can just create a login or like even without a login, watch content. And the catch is that like we use advertisements to generate revenue. We have about 33 million active users, monthly active users so far, and there are about 30,000 titles in the service. So as you can imagine, machine learning is a core and very important component of the system. And as you can imagine, there are like the most important area for machine learning is content recommendations. In recommending what content should users watch, what content should every user watch out of the 30,000 titles that we have. Content understanding is another big crucial piece of it, and ads machine learning is a third important part. So let's try to have a closer look at the content and what sources can help us get much more information about a content. So the biggest source that comes to my mind when I think of content is IMDb. In IMDb, you can see a lot of information about the title, when it was released, cast, synopsis, reviews, etc. Many sources like IMDb, another big one is Rotten Tomatoes. Grace Notes is another such source. There are more sources like this, like Metacritic, etc. Then, of course, there is Wikipedia, where you can get so much more knowledge. And along with that, you can also use the content itself to generate textual information in the form of subtitles, transcripts, and maybe even some video analytics can be used to help generate some textual information. So taking a deeper dive, here is a title that was at Tubi a couple of months ago. And so what do we know about like this big title, The Hunger Games? We know the cast. We know the metadata. So the metadata could be in the form of a synopsis or a description of what the title is about. We know the genre. The genre could come from the various sources like IMDb, etc. We also know the reviews. We also know how did the previous users like this title or not. Another very critical piece of information is the box office for the title itself. So over here, we can see that like the Hunger Games generated $408 million in the box office. And that's like another critical piece of information that can help in our understanding of the content. And of course, we know the IMDb ratings, the different ratings from the various sources that can help us inform how users perceive of this title externally. So what is content understanding and what can it help? So first of all, content understanding is trying to understand the different information that we have about a title. It can help us improve our understanding of the user preferences. It can help us improve our recommendations itself. It can help us influence the content buying decisions. It can help us improve the cold starting behavior, and it can also help us improve the content categorization, or generate the different subcategories or the rows that you see at Tubi.
Sorry, Jaya, that I'm interrupting you.
Yeah.
It seems that we can't hear you clearly, and maybe it is a connection problem, but most of the attendees can't hear you. Could you just recap from a little bit, from the previous slide? Because now I think we can clearly hear you.
Now you can hear me?
Yeah, clearly.
Oh.
Thank you
Oh, no.
so much. Thank you.
Yeah, very sorry. Very sorry that.
Thank you so much. Sorry
Yeah.
to.
Yeah. So you just want me to recap from the last slide, right?
Yes, if it's
Okay.
possible. Yeah, thank you so much.
Yeah, definitely. And please feel free to interrupt me if you cannot hear me once again. I cannot see the chat right now because I did a full screen. But what I wanted to mention was what is content understanding and what can it help us? So content understanding is trying to understand the different pieces of information that we have. We have so much more textual information. We have so much more metadata, and we have so much more like additional data from the external world. How can we use this information to help us better understand what a title is about, and which users would like this title? So it helps us improve the understanding of our user preferences. It helps us understand the titles better and improve the user preferences for the title. It helps us improve the recommendations that we provide at Tubi. It helps us influence content buying decisions. This is a big use case of content understanding at Tubi. Because once we understand like what title clicks at Tubi, and it's not always, you will see that not always the biggest blockbusters click at Tubi. You will see that like their Tubi audience is very different from the overall audience. So like maybe the audience likes some titles much better. And so it helps us like influence the content buying decisions itself. It helps us improve the cold starting behavior. So whenever a title is launching at Tubi, we do not know any information about the user feedback at Tubi, but we have so much more information about the title from the external world. So all this information definitely helps us improve the cold starting behavior. Finally, it helps us improve the content categorization. By content categorization, I mean the different containers or the different rows that you see at Tubi. We can like help create many more different categories of content if we understand the content better. So let's directly jump in into what is deep learning for NLP and how it can help improve the content. So what is NLP? I think a lot of you already know this. You don't need this introduction at all. But just to recap, NLP is an area that is at the intersection of computer science, artificial intelligence, and linguistics. The goal of NLP is to help computers understand the natural language in order to perform useful tasks such as question answering. And then there are many more useful tasks where NLP can be used. So what can NLP actually help achieve? So over here, I have listed few tasks ranging from the easy ones. I call them easy because like it has been, keyword search is very widely used. So keyword search, review classification, whether this review is good or bad, I call them like is easy task. And then there are like medium tasks like topic extraction, embedding generation. And then there are hard tasks for NLP, which I think we are still trying to solve and trying to understand, like semantic analysis, machine translation, and question answering. So why is NLP hard? So here is a real example of a row that we were trying to generate at Tubi, kids horror. So when I say kids horror, I think all of you understand that what I want is horror titles that kids would appreciate. And I'm not looking for any titles to make the kids horrified at all. So there is a lot of ambiguity in representation and learning, and that makes NLP hard. So let's start with the very basic thing, which is representation of words. The first and most common denominator across all NLP tasks is some representation of the word itself. A very simple representation is a one-hot vector representation in which the length of the vector represents the length of the vocabulary, and a 0 or 1 indicates whether the word is present or not present. So as you can imagine, this is a very simplistic approach. There are many problems with the approach. Some of them are the curse of dimensionality. The dimensionality of the vector becomes very large as the length of the vocabulary increases. It doesn't capture the meanings at all. So for example, over here, you will see motel and hotel are far away in the vector space, like the similarity between them is 0. The neighborhoods are not captured at all. Uh, so what is done recently, and um, this is coming from a lot of literature in the past. There are two approaches generally used to represent the text. Um, One of them is the continuous bag of words approach, in which you want to take the neighboring text into account and predict the center word. And the next one is the skipgram approach, in which you want to predict the context word given the center word. So this helps in creating the neighborhood relationships, and helps in preserving the neighborhood relationships, and in coming up with word embeddings that make much more sense. So word to vec, most of you must have heard of it already. But just to give a quick recap, word to vec uses the similarity of the word vectors to calculate the probability of the outside context word given the center word, or vice versa. So the idea behind word to vec is to keep adjusting the word vector to maximize this probability. And more details can be found in the basic seminal paper, or like I think you will find like tons of resources online explaining that. Um, so what is important to us over here? We have a lot of like documents in the form of text, in the form of reviews, in the form of synopsis, etc. So what probably we are more interested in is having a document representation. So doc2vec is an extension of the word2vec, in which you create a numeric representation of a document instead of a word. So what is being done is that like you add an additional paragraph ID to the context of a word, and that helps generate the document embeddings itself. So let's have some embeddings fun. So over here, I want to show some examples in which we used doc2vec, and we used all the text embedding, all the text data that we had to generate some of these results. So, and all of these titles are titles which are from Tubi. So if you look at training day, the document vector for the training day, if you add it to super bad, what you get is a vector extremely close to 21 Jump Street. This is my favorite one. So if you pick up Gladiator, embedding of Gladiator, if you add them to Princess Diana, it amazingly becomes extremely close to Boudica, warrior queen of ancient Britain. I thought this was really bang on. Similarly, if you take Star Trek, add it to Godzilla, you get something like Pacific Rim. I also like this example a lot. I think this, to me, it made so much sense. Let's take a simple example of subtraction. If you take Eat, Pray, Love and subtract the notebook out of it, what you get is Hector and the Speech for Happiness. So that was just some simple examples using doc2vec. Let's move on to what additional thing that can be done on the text data that we have. So any mention of NLP is incomplete these days without a mention of BERT. A BERT is considered the state of the art in the NLP models. And so what is BERT? BERT is basically a bidirectional encoder representation from transformers. It was published in 2018, I think, and is now considered the state of the art in various NLP tasks. It's a bidirectional model and it's a very popular attention model. The pre-trained word embeddings also exist, and they are trained on two main tasks: mask language prediction, in which you mask some words and then you want to predict the masked word, and next sentence prediction. That is, you want to predict what would be the next sentence given the sentence that you have seen so far. Uh, so a word of caution with the pre-trained embeddings, and this is something that we discovered as well. Um, when should you use pre-trained embeddings versus when you need to fine-tune for your own specific task? So if you look at the pre-trained embeddings, you will see that the similarity between, so the saved query and the new query, and this is an example that I picked up from this blog, the saved query and the new query show very high similarity even when the text doesn't make sense. Like for the last example, blah, 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 and does this integrate with Gmail doesn't make sense at all. And even then, the similarity is very high. Um, so um, you might have to fine tune for your own specific task when you are using both. Um, so another thing that we use heavily and that which is very important for representing the movie information is knowledge graphs. So knowledge graphs are, I know that there was a session already on knowledge graphs, and I want to specify that for movies as well, the knowledge graphs make a lot of sense because knowledge graphs are a way to represent your facts, which consist of entities, relationships, and semantic descriptions. So, for example, in the case of, let's pick up this example. Figure you have the movie Forrest Gump. We know the director is Robert Zemeckis. We know the actor was Tom Hanks. Tom Hanks also acted in the movie Terminal and also acted in the movie Castaway. The language of both the movies was English. The year in which the Terminal was released was 2004. So, thus, we have a graph in which we have different kinds of nodes and different kinds of relationships that exist in the graph. So, knowledge graph allows us to model the information intuitively and very expressively. And it's also a very powerful way to capture all the metadata information that we have for a title. What are the different use cases of knowledge graphs? So first of all, knowledge graphs have many, many more powerful use cases. But what we are looking at is just constructing the embeddings out of these graphs. Generally, people talk about three main ways to construct the embeddings. Translational, in which you learn the translations from the head entity to the tail entity. Trans-E was a seminal paper which was published on translational embeddings. Bidirectional, it uses a multiplicative approach to represent the relationship as matrices in the vector space. There are some good important papers in that direction as well. And finally, neural models. So models based upon neural network, and I think there are a lot of examples over here. And maybe graph-based neural networks also can form a subcategory of like this knowledge graph embeddings. And there is a huge literature around that space as well. So I also want to highlight some of the lessons that we learned overall throughout the process of content understanding and trying to use the different embeddings for our use case. The first thing is not all text is the same. And while this may seem very intuitive to you, when we are throwing all the data into the embeddings, it is not very intuitive to the neural network model itself. For example, reviews are very different from subtitles, and they are very different from synopsis. So I think the important fact is to understand that like the text is not the same. And the reviews can have, for example, a lot of grammatical errors. They could be short, they could be incomplete, they could reflect the sentiment, and they could not reflect the summary of the title itself. So be careful when mixing the text from like the different sources. Uh, Different tasks could require different tests. For example, sentiment analysis could require completely different text. Over here, I show two examples of the reviews. One says, I really like the movie, other says, boring and predictable. And this is particularly useful for sentiment analysis and might not make any sense at all for summarization of what the movie is actually about. Finally, I want to say that averaging is used very widely. You construct an average embedding for a title using like multiple reviews that you have. You just average them and say that this represents the embedding of a title. It's very widely used, but it loses a lot of information. So be very careful with averaging. Uh, Another thing, yeah, I want to highlight, like as I mentioned before, is that be careful with the choice of algorithm and what it is suitable for. There is no free lunch in terms of algorithm and representation. So every algorithm and representation comes with its own nuances, and be careful to understand that. Um, an important task, which I think like all the people working in NLP already know, is that pre-processing and cleaning up is very critical. Is very critical. Uh, Finally, evaluation is very hard, but extremely critical. So, for example, when we are generating the embeddings, and these embeddings could power a lot of different use cases, how would you actually assess the quality of embedding when you change something small? So you could use the downstream application, but that could be far away, and the downstream application could be many of them. So what is the particular thing that you can do to do some like embedding quality assessment? Maybe you can define some kind of a surrogate task, which is in between the actual downstream application, but also closer to your embedding original training task. And then you can assess your embedding quality on those surrogate tasks. So evaluation is also extremely critical. With all that in mind, I want to tell you about our platform for content understanding. So we call it Spark, and we hope that like Spark helps us understand the content completely. So what is the idea behind the Spark platform? The idea is it's a platform for data ingestion, pre-processing, and cleaning. And we generate a variety of embeddings to power different use cases across the product. And we also have assessments to help assess the quality of the embeddings via the surrogate task. Um, so here is a brief picture of like what is happening in the content understanding process. We have the first and third party data. We have the universe of like content, metadata, etc. All this information goes into Spark. Spark pre-processes, cleans them, and then generates products which could be in the form of like embeddings, which could be in the form of models, or which could be in the form of a beam from the universe to the Tubiverse. And this beam is particularly helpful in cold starting of titles. So apart from cold starting, yeah, there are like several use cases that we can use the content understanding to power: content value assessment, portfolio analysis, tiering. So tiering of titles, when you want to bring a new title to Tubi, uh, how much how much revenue will it generate, or what is the tiering, how much total view time will it generate? That's also an important problem for us. And so tiering, it can help in tiering. And remember that like it is not as easy as just using the IMDb or box office, and it never translates directly from the ratings and the box office into the Tubi space. So maybe audience preferences are very different in the product, and also maybe people like watching certain content on AVOD versus people like watching certain content on cinema also. There is a, yeah, we have never seen that like it, if you just pick up the highest IMDb rating title, it will work very well across the product. Um, Search, seeding of growth, audience assessment, these are like the new use cases that we want to help power. Uh, Future direction. So we while we generate all these embeddings, I think we still have a lot of work to do to improve our understanding of the natural language to better construct the embeddings. Different languages is another thing, like it's another challenging problem. Right now, to be expanded in Mexico, but as soon as we go into more international territories, we need the ability to understand the reviews across different languages and how can we construct the content out of these. Finally, I feel that there are so many different use cases that can be used to understand content and generate different embeddings for those different use cases. But at some point, I think it will come to it that how many that you will have to unify the embeddings. Probably all of these embeddings don't make sense. They exist. Maybe they make sense separately, but maybe it is useful to combine them and generate some kind of a unified embedding. All right. So here are some of the references. Christopher Manning and Richard Sauter's NLP course. We use Hugging Face transformers extensively for generating like the embeddings. Acknowledgements. I want to acknowledge that this is the work of the machine learning team at Tubi, in particular John Renkel, who is the principal engineer and architect of Spark. And finally, thank you so much for listening. We are hiring, and you can feel free to email me for any questions or anything. And also, here is my Twitter handle. That's all I have. Thank you.
Thank you so much. I really enjoyed the talk, and I'm sure the attendees enjoyed it as well, because we get a couple of questions. Let's get to the questions. Does your recommender system look at the video content?
Video content, I would say honestly, right now we don't look at video content as much as we should be. Yeah, we are working on some use cases in which we want to look at the video content, especially in the ad world. Actually, we had something which does computer vision on top of the video content to help us identify like brands, but not in the rest of the recommendation space right now.
Thank you. And another question is, do you think can BERT be used for topic modeling as well?
Yeah, I have seen, yeah, there are some cases in which BERT and maybe extensions of BERT are used for topic modeling. I don't remember the name on the top of my head, but I remember seeing an extension which is used for topic modeling, and especially for topic extraction.
Thank you. And for the doc2vec, what's your corpus for the data set for movie similarities?
So the corpus is whatever we have, all the information that we have for the titles. We just threw in like so much information from Wikipedia, synopsis, IMDb. We have partnership with IMDb and Rotten Tomatoes, and maybe a couple more which I forget. But that helps us get much more data, and we just throw in that data into the doc2vec, especially in the example that I was showing you.
Thank you. And there's some general questions, even audience discussed this in the chat section, but I want to ask you as well to have your thoughts as well. Does BERT work with French or other languages? Or another question related to this question is that, for example, is that doc2vec API available in Tubi or somewhere else, and or not?
Yeah.
I know we have Hugging Face, but do you have any other suggestion?
Yeah, I think there are for doc2vec. You can just search online and you will see like you will find a lot of like implementations of doc2vec. The other question on BERT was, we specifically use like Hugging Face for like BERT and the different variants of BERT. But doc2vec, you can find, I think just probably you can find some like PyTorch or TensorFlow implementations of it. These algorithms have become so much of a standard that that there are like, really good implementations available. So the question on BERT was, can it be used for French? Actually, that's a good question. I personally am wanting to solve that question, because as we are expanding, we are seeing that like we are in Mexico right now and we want to use the Spanish content, Spanish reviews, etc. and we are not doing so well on right now in terms of trying to understand the content from other places. But I'm pretty sure um, uh, if we search online, I'm pretty sure like Google and others might have some answers to that.
Thank you. In terms of model performance, how do you monitor model performance after deployment?
Yeah, that's an extremely good question, because like these, let's say that the model is generating embeddings and then it's used to power some other use cases. This could be a very simplistic use case, or the model itself could be a deep learning model itself, which is powering the use case. So if the model is a deep learning model itself, which is powering the use case, then the monitoring becomes easy. Like all you need to do is like do your usual model performance that you do for in otherwise as well. But if let's say that you're generating the embeddings and then the embeddings are used to power the different algorithms, then you need to be careful. For example, if you changed something in the embedding space and you want to constantly update your embeddings to take into account the new data that you have, the new reviews that you get for the titles, the new information that you get for titles, etc. So you want to constantly update the embeddings, but you want to be careful that it doesn't break anything in production. In particular, you want to assess the quality of the embeddings that are generated are not bad and are in the right direction. So we have some surrogate tasks in place to help monitor that. But yeah, there are many things that which can be done in this space.
Thank you. And what are your use cases for knowledge graphs? Because you mentioned knowledge graphs earlier.
Yeah. So knowledge graph actually fits in very well. Like if we look at like the slide once again, so knowledge graph fits very well in the Tubi metadata space, because we have a title and we have so much information in the form of a graph for a title. So ultimately, what we want to do is understand the title better. So knowledge graph like helps create, and ultimately, or at least my goal is like everything should fall into the knowledge graph. So even if you have like free flowing text, maybe you generate the embeddings out of that, and that also becomes a part of your knowledge graph. And then the knowledge graph creates some giant embeddings which can help power your use case. So graph to me seems like a really good representation of the content, because like currently like any representation, any text representation fails to capture the relationship. For example, Tom Hanks is an actor in Forrest Gump, also in Terminal. So this relationship is completely lost if we just look at the text and try to capture the text embeddings. So knowledge graph is very powerful in that sense, that it helps bring together those like network relationships and a different like semantics that we can exist in the relationships. So that's why I feel knowledge graph is very important.
Yeah, you're right. I completely agree. And one last question is that is your work, I mean, the Spark is open source, and if it's not, do you have any plan to make it open source?
We do not have it open source as of now. I think that's a good question. Maybe we should try to open source some of the things, some of the good things, and make it a good platform. I think that's a good question.
Thank you. And another question came up. In your opinion, can knowledge graphs help in topic modeling as well?
Yeah, this is my personal opinion. I feel that knowledge graphs could be very helpful, but it all depends on like what is your particular use case, and what text goes into the use case. So for example, if you have free flowing text, maybe you can use something else, like use some summarization on top of BERT, like some extension which can help you generate the topics, or can do topic modeling better. This knowledge graph, I think, is more suitable when you have some kind of a structure as well in your data. Like in the case of movies, it's very clear that there is some structure, there is some graph structure in the data. So
yeah, you're right. Thank you so much. Thank you. This has been a great talk. I really enjoyed it. And I really appreciate you talking at TMLS. And I want to thank you and thank you all of our attendees for joining this session. Hope to see you again in another talks. Thank you so much.
Thank you so much. I really enjoyed this conference. You guys are amazing. Thank you.
Thank you so much.
Thank you.
Bye.
Bye.